The other type of radical function that we're going to look at is cube roots. Now, the generic look to a cube root isn't altogether dissimilar from our square roots. The only other thing being that the index is 3, and each of those variables in their respective locations has the same impact. A controls vertical dilation and reflection in the x-axis. B controls horizontal dilation and reflection in the y-axis. H is going to control horizontal translation, sliding left and right, and K is going to control vertical translation, sliding up and down. Now let's get into actually seeing these things happen. If we're going to graph the cube root of x plus 1 minus 3, again, this all starts with understanding the parent curve. Now our parent curve has a very simple structure to the points that exist in it. They're perfect cubes. Well, the simplest perfect cubes are -1, 0, and 1. If we went out further, the next nice value on the right would be the point 8, 2. Out further on the left, -8, -2. It's more than we need to keep track of as long as we keep this generic shape in mind. Again, spacing is important. Moving from that point of inflection in the center, we only have to go right and left 1 unit and then up and down 1 unit to find those other 2 points. We just need to be very careful that we don't decide to connect them with a line. This should still be a curve. Looking at the graph that we're actually attempting, we're going to go left 1 and down 3. So that point of inflection, the 0, 0 point, that middle point, becomes the point -1, -3. Now from there, I use that same spacing. In blue to the right, I move right 1 and up 1. That's where I find a new point. Purple to the left, I move left 1 and down 1, and I draw a smooth curve. Domain and range, they're freebies on this function. Domain and range are going to be -infinity to infinity, regardless of what we do to it. There isn't any transformation that will change that.